So we're going to continue on from the last lesson where we did simplification of harder expressions. These are really just continuations of the things we did last time, but these are even harder, right? So we're going to go straight into them. Uh, I'd like you to have a go at them now. So pause the video, have a go. All right. So now that you've had a go at these, probably would have taken you quite a while. They're fairly messy expressions. They're very easy to get wrong as well. So let's go through them. I'm going to start by moving question 2 out of the way. So we're just going to move question 2 all the way down here. All right. So question 1, what we have is a fraction with a polynomial on the top, polynomial on the bottom, polynomial here, linear term here. These are things which we can factorize. So whenever we have expressions which have polynomials, with the exception of the x plus 2 is just going to stay the same, but we're going to factorize everything else. If we factorize things, hopefully when we multiply or before we multiply, we should be able to cancel. So for the first one, this is a non-monic. This is 2x squared plus 20x plus 32. This is a trivial non-monic, right? Everything's divisible by 2. So we can take 2 out the front. This becomes x squared. 20 divided by 2 is 10 plus 10x. 32 divided by 2 is 16. We are looking for two terms which add to make 10, multiply to make 16. Well, this is actually the same expression as the denominator. And this is very convenient because we could simplify this more, but we don't necessarily need to. So we can leave 2 as it is because we know it's going to cancel with the term in the numerator, x squared plus 10x plus 16. We can leave that, and we can leave this in this form. 3, this is the difference of squares. So we have x squared minus 4. We now know this is x plus 2 times x minus 2. It's always the square root of the first term plus the square root of the second, and the square root of the first term minus the square root of the second. And then our fourth term is just an x plus 2 on its own. So let's sub all of this in. Let's write our fraction down here. The first one becomes 2 times x squared plus 10x plus 16 over x squared plus 10x plus 16 multiplied by x plus 2 times x minus 2 all over x plus 2. In the first fraction, we can cancel this and this before we even do the multiplication. In the second one, we can cancel x plus 2 with x plus 2. We are left with two terms in this expression. Let's get this out of the way. Move this down. We are left with a 2 here, and we're multiplying it by bracket x minus 2. So this is just a bracket expansion. 2 times x is 2x. 2 times 2 is 4. There's a minus between them. So this is 2x minus 4. And this process worked a very specific way. We tried to factorize everything as much as we could. We got lucky with this one. Both the fractions simplified fairly quickly. You might get other ones where the fractions don't simplify quickly. It's actually quite slow. You might get terms in one fraction canceling with terms in another. So that means you need to do the factorization first and then cancel once they're all in one big expression. As long as you end up with whatever the correct solution is and it's as simplified as possible, you've done the right thing. All right, let's have a look at another one. This is a very chaotic question. It's got a lot going on. So what we're going to do first is we're going to do all of the internal bracket simplifications first. So we're going to do this one in blue, and then we'll do this one in green. So if we do the one in blue, we'll do that in the color blue. So this is a on 3 plus 7 on a. So addition of fractions, multiply this by a, this by a, this by 3, this by 3. A times a is a squared, 3 times a is 3a, 7 times 3 is 21, a times 3 is 3a. So this is a squared plus 21 over 3a. So that's what this is equal to. Then we need to do the green one. So this is a on b times a on 2b. A times a is a squared. B times 2b is 2b squared. So this is this green. So now let's rewrite our original expression, replacing the blue with the simplified blue and the green with the simplified green. So we have the whole thing is equal to a squared plus 21 on 3a, and that is multiplied by b on 6, multiplied by b over 6. This whole thing is divided by the green one, which is a squared on 2b squared, a squared on 2b squared, and that is divided by b, divided by b. Well, now what we want to do is we want to simplify this numerator on its own, simplify this denominator on its own, and then put them back into the fraction. So we'll do the numerator. This is process 3. We have a squared plus 21 on 3a multiplied by b on 6, or fraction multiplication. We get a squared times b is a squared b. 21 times b is plus 21b. This is all over 3a times 6, which is 18a. These don't cancel, so this is this yellow bit. Now we need to do the denominator. Well, this is a squared on 2b squared divided by b. Well, b is actually b on 1. Any term on its own is that term on 1. So this is a division of fractions, so we can inverse the second one, turn it into a multiplication. We get a squared on 2b squared times 1 on b. A squared times 1 is a squared. 2b squared times b is 2b cubed. So now we've done this one. So let's rewrite our expression. The numerator is the yellow, the denominator is the red. We've got a squared b plus 21b over 18a, and this is all divided by a squared on 2b cubed. Well, this is a division of fractions, right? It's just a standard fraction. So if you have a on b, this is actually equal to a divided by b. So we're going to write this as a division. So the numerator is the first term, a squared b plus 21b over 18a, divided by the second fraction, which is a squared on 2b cubed. So division of fractions, so flip the second fraction upside down, turn it into a multiplication. It becomes a squared b plus 21b over 18a times 2b cubed on a squared. Multiply numerator, multiply denominator. We get 2b cubed in front of a squared b plus 21b over 18a. Now there's no b's in the denominator, and there's some a's in the numerator, but they're not cancelable. There's a 2 up the top and an 18 down the bottom though. So both of these we can divide by 2. This gives us b cubed in front of a squared b plus 21b all over 9a. Expand the bracket up the top. B cubed times a squared b is a squared b to the 4 plus 21b times b is 21b to the 4. This is all over 9a. And this, sorry, we're missing a cube here. There should be a squared here from the a. So we have a cube here, cube here, cube here. This is our solution. Now you noticed in the last bit, I almost forgot a cube, right? It's very easy to lose or gain signs here, lose or gain numbers. Just forget to write them down. No matter how good you are at these, you have to be very careful, because you might not recognize that you've accidentally lost or gained a term when you're doing your working. That's just because there is so much working, right? This is a fairly long question. It's only a year 11 question. It's really like a year 10 hard algebra question or year 11 hard algebra question. You could get something like this in an exam and it could be worth quite a few marks though, because the chance of you messing up on a question like this is fairly high. If you are doing these questions and you have answers provided by your teacher and you happen to know that an answer is wrong, you're going to be very unlikely to find where you've gone wrong in the question, right? Because there's so much working. I would recommend the best strategy in that case is you scrap the old working and you just start again, you work slower, right? If you understand how every individual little process is working, you know all of the little pieces to get the answer. But one of them has gone wrong because there's so many of them, it's hard to tell. So with these questions, work very slowly. It's more important to get them right than it is to do them fast, especially if you're getting them wrong. Right? Work slowly through them, make sure you understand each little bit you're doing, and you're more likely to get them right.